In this Grasshopper tutorial, I'm going to show you step by step how you can make this parametric building by defining a series of points as the location of the charge of the Metaball custom, which I'm going to explain step by step. Any charge we want to these points, and control the height of each of these floors, and how many sections we want to delete those areas that are less than this number. We can also offset each of the rooftops of each of those floors, and also the building floor, which you can see here. We can control the offset of that. So this tutorial is going to be step by step on how you can model this building. Okay, let's get started from scratch. What I want to do here is to use the mesh triangulation and use the Metaball T custom component. And let's go for the full name. The first input is the points, so I can just right click here and extract it, and right click set multiple points. And as we are defining the points as the charge location, we have to also define the charge which is only positive. And what you have to do here, because we have 5, we have to also define 5 different numbers for the charge for each point. To do that, I can go to the params menu and go to utility, use this gene pool. It's just a series of number sliders compacted into one. I can double click it and select 5 because we have 5 points, and 0 to 100. Okay, and I can give that to the charge. Because by default the plane is XY, here you can see that this is like the first point, the second point, the third, the fourth, and the last one. Okay, because I want them to collide, I'm going to increase the maximum to maybe 500, and here you can see that they are colliding as we increase. Or we can change the location and get different outputs. Okay, then the next thing is defining the plane. This is actually a 3D series of spheres merging together, but we are only seeing the XY plane, which is actually the default plane we have here. We can define a point here. I'm going to right click and set one point and make an array of these points to actually control the location of the plane. So I can go to transform a linear array and say, okay, in the direction Z, giving it the factor, it's going to be the space between the points, or this is the floor's height. This is going to control the floor's height, and obviously the count is going to be the number of sections we need. We can increase or decrease that. Because we are giving a series of points to the plane, it's going to assume that they are XY planes. So remember that when we give this to the plane input, it's actually defining them as an XY plane. So this is also a trick you can do without getting any plane. If you want an XY plane, you just give those points to the input. And here you can see that by increasing this point, these points that are there's no intersection, because the shape is actually something like this. If I bring it down and make this a little bit smaller, you can see that these are actually the spheres colliding together. So if I play around with these points, you can understand how they are working. Okay, so we are actually, the Grasshopper doesn't give us the mesh, it only gives us the ISO curves, and that's why it's really fast. So we just have to play around with the inputs of point charges and planes to get it. We don't really want to mess up with the threshold or accuracy, we just want the ISO curves and go in the next step. So what I want to do here, because I want to make it a building, I'm going to bring it a little bit up and say that they are going to start from here. And obviously we don't need that much of points, but anyway, If you decrease the height, then you have to increase the number of counts. So remember that this is also important. I'm just going to turn that off and increase the height of those buildings. Okay, when we have the curves here, the most important thing is that this is a polyline. So if I zoom in, you can see that they are completely polylines. Okay, now that we have the isocurves, what I want to also explain is that first of all, there are some groups which have 0 outputs like this. If you want to see it, you can go to the param viewer from the params menu, and here you can see that we have lots of groups that are 0. If we wanted to get rid of them, we can go to set tree clean tree, or just search for clean. This is the icon, and we have to give it to the tree input and the tree output. And what you have to do here is to say remove the empty to true. Because it's false, we can either go to set boolean to true or just right click and invert it. And now you can see that the branches is clean. And the reason here is that because we had some points here, obviously they don't have any intersection, so we can get rid of them by using this clean tree. Okay, so remember that you can always remove any empty, invalid or nulls. By default, the remove invalid and nulls is true, so we don't have to mess up with that. Okay, after producing the polylines, what you can do here is to either connect a surface to that. Let's go to the shaded mode and see that, which you can use this one. As you can see here, they are a polyline. Another thing you can do here is to use the surface boundary surface. The boundary surface, the good thing about the boundary surface is that if it has any holes inside it, for example, if I want to make another copy of this and go to the charges and say the expression is like 0.5 multiplied by x, that means a little bit smaller, but they are in the same plane. So if I bring this into one curve container and I have this boundary surface, you can see that it's going to produce some series of holes. Let's just decrease the number of sections so you can see that even better. And here you go. If I wanted to see it, I can connect a custom preview. And let's turn on the edges also. And here you go. You can see that you can also change this multiplication, maybe just say multiply. And instead of typing this 0.5x, I'm going to just type a number between 0.1 to 0.9. And you can see that you can also use this method to actually create the boundary surface. But when you connect a surface to it, the problem with the surface is that it's not going to give you the correct output. You can see it's completely full. So let's just delete this and connect that to the brep. I'm going to save this file, so if you want to, you can download this example file from our website. Okay, anyway, because we don't want to get messed up with the negative charge, which is just actually getting rid of those circles inside it, I'm going to disable this and go forward and explain about making the building. We can now increase the number of the count. Also, to make this a little bit cleaner, what I want to do here is to make this wireless hidden. So this is going to just make it a little bit separate from our algorithm. So you can just use that, and we can also go to the next step. Okay, what I want to do here is, before I make the boundary surface, also explain that this is a polyline. So if you want to, you can also convert that into a NURBS, a curve, utility, rebuild curve. Put the degree to 3, which is going to make it NURBS. And the number of counts is just actually the number of control points you want. Okay, because this is a little bit small, and let's see the control points. 120 control points is a lot for this one, right? And that's going to give us a little bit of a jaggy NURBS. But anyway, this is the number of control points you want to define. So if I decrease it, you can see that's somehow like a smoothing mechanism, but the good thing is that this is completely smooth and you have a series of NURBS edges. Okay. Another thing that okay, so I can just bring that here and say that the boundary surface is like that. Another thing I can do here is say to delete those areas that are smaller than something. Let's analyze that by going to the surface area and finding the area of each of these curves. And here you can see that this is the area of those sections, right? I'm going to just flatten this because I want to see all of the areas in one group, not in the separate sections. And what you can do here is sort them. You can use different methods to extract the maximum. One is that you can sort it from smallest to biggest and then just pick it up with a list item. This is like the smallest area. Or you can go to math, use this bounds. It's going to say it's between this number and this number as a domain, and then deconstruct domain into minimum maximum. This is also like minimum and maximum. Okay, so just use whatever method you want. There are several ways you can do that, and this is like the smallest area possible. Okay, so what I want to say is that is it smaller than a number? Again, I'm going to make a copy of this because I don't want to get messed with the groups, and this flatten was just to find the smallest area so you can see it in your project and you know what it's producing. But let's say we want to say in the math smaller than, check if the area is smaller than maybe 220. Get 2 decimals and say area smaller than, and now it's going to give you a series of true falses, and now you can use this logic from set, list, and dispatch. If you don't know about this, you can enroll in our course, Para course. We have a complete section for data management. But anyway, this dispatch, the logic, you test something, a number, then it gives you a series of true falses. Then you can use this logic as a dispatch pattern and dispatch all of those curves here. Okay, so what's going to happen is that it's going to give you 2 set of groups of curves. One is those that are smaller than this number. If I increase that, you can see we are getting more curves, and a series that are bigger. We're going to use them as the output. Again, we have some zeros. That's why we have planar surface return no results warning. It's not really that important, but if you want to get rid of that, again, clean it. It's not a big deal. And we will have that. We can increase this number maybe to another dimension, and you can see it's just deleting those that are smaller than this number. Okay, that's it. Even if we have a series of sections from the top of the metaball, so it's okay. Okay, after producing the surface, we can go and work for the facade, the rooftops, and whatever. Okay. For the rooftops, what I can do instead of making it a boundary surface, I can offset it. So let's go to the curve, utility, and say there are 2 tools we can use here. Let me just highlight this. Offset curve and offset curve loose. And the curve loose is also good, but it's going to mess up with some of the planarity of the curves anyway. But I'm just going to show you that this is an offset. If we offset that too much, it's going to break. And if we offset that with a simple offset like a distance, it's really slow. As you can see here, it's like 5 seconds, and with the same number of distance, it gives you, let's just go with this, a clean offset. So if you want to have a faster output, you can go with the offset curve loose. If you want a really exact output with cleaning, you can go with offset curve, but it's really slow. So remember that that's going to slow down your project. I'm going to disable this and use this one and offset this like that. Even if it's breaking, you can see it's making the surface okay, because we don't mess up with the breaking of the offset. So I prefer to use this offset curve loose, not the offset curve, because it's slower. And just turn this off. You can see that here, even if we offset that too much, it's going to fix the problem instead of just slowing down the process. Anyway, this is like the top of the roof we wanted to offset. We also want to get rid of the first one, right, with the first section we had here. So let's go and fix this part. So I'm going to delete the offset curve anyway. I wanted to explain that how we can dispatch them into groups of 2. So here in the tree, if I simplify that, so we get rid of the zeros, you can see it's those sections we had in those points, right? And this is like the ground floor. I want to, for more exercise, get this out so we can give it a separate offset than the roofs, and also extrude the other things up. Okay, so we have to get rid of the 0 and have the rest here. One of the methods I usually use is to go to set tree and use this split tree. I really like it because it's easy to manage, especially if you simplify things and get rid of the zeros. Give it to the data and then just say, for example, I want to get rid of the 0. But let's make it a number slider so you can see it. If you give it to here, it's going to give you an error. Just simply go to params menu, primitive, and give it a data path. It's going to convert it into data path 0. Remember, you have to simplify that. And now you can see that this is going to give you the 0. And as you go up, it's actually going to put the groups out into groups. Okay. For example, if I give it like 2, just check this out. We have the group 0, group 1, and then we don't have the group 2, and then we have 3, 4, 5 till the end. Okay, so that is actually a way you can split the trees, but I'm going to go with 0 because I want to have the ground floor here and the rest in the negative, and then we can give that to the offset and go and work with it. Okay, so that's it. The splitting is also another technique I wanted to explain in this tutorial. And now we can extrude this a little bit down. I'm going to say surface freeform extrude. The direction is going to be Z, but because I want to bring it down because we deleted the first one, I'm going to go to the direction and make it -6. As you can see here, this is really slow, and that's the reason I don't want to work with polylines. It's really slow. So what you have to do is to just be sure to have the rebuild curve. Okay, just replace this one with the rebuild curve, and here you go. You can see how fast it is. It's really cool, and the extrude is really fast. And then we have to give the direction a -x. It's coming down. And how much do we have to give this as the extrusion down? Before I wanted to do that, I also want to extrude this one up as the rooftop, the offset. The offset is going to go up. It's better to extrude the surface so we have a solid. So now we have to control the thickness of the roof and the facade. If I go here, we had this floor height, so I'm going to go to the math and say minus, and for example 0.87, this is the roof thickness. Okay, and this is going to be the facade. So this is the roof thickness, this is the facade height. I'm going to just make this a wire display hidden and bring it here. Okay, so this is for the roof thickness. Let's make a Z for this one and give it. Okay, so this is going to control the roof thickness, and this minus is going to be the facade part. So if I go to the front view, you can see that this is going to give us the roof thickness, and this is going to make the facade. We have also the bottom, but anyway, this is going to fix the problem. For example, if I zoom in and get a distance, here you can see that this is actually the number down here is 0.7, right? Just check down this number, or you can say distance from here to here, and here you go, you have this 0, something near that number. Okay, just wanted to show you that you can control the roof thickness by that, and the rest is going to be the facade. So we have now, just get rid of this one, you can give a color swatch to the roof, just turn off everything, and another color for the facade. If I want to say blue, and if you want to see the edges, just use this B-rep edge. Okay, so now we can just start experimenting with the location of the points. You can see it's really faster than polylines because we have those extrusions. We can play around with the charges. We can define smaller than, so if I decrease it, these are going to pop up because they are also the smaller sections we have here. Anyway, now that we have the outputs, we just have to work with the facade windows. I want to also give you a trick for the windows. To do that, I usually love to use the Launchbox plugin. I think the Launchbox is also good. So let's go to the Launchbox. And panels, why not use a quad panel? Okay, let's give it like this. The U division is the height, so I'm going to give it a 1, which is the height. And now what is the number of division here? So remember that you can use a mesh or you can use Launchbox, but I'm going to use Launchbox, this plugin, in this tutorial, sorry. And now you can see that we have these panels like this. So how can we control these numbers? What I have to do here is to play around with the curves what I have here. Okay, I'm going to just connect a number to it. It's going to extract the length of these curves. And for example, I'm going to say divide it with the width of the window. So for example, it's like 1.45 window widths, but remember this is like approximate because it's going to be a division, and then I have to give that as the V division. Okay, this is like, we have to increase that number, and now we have those windows with this 4 meter, for example, length, and it's going to work all the top. If you want to give it a frame, again, you can go to the Launchbox plugin and use this one, frame, panel frame, and we're going to say a scale between 0.1 to 0.9, scale factor. Let's zoom in, make this a little bit bigger just for preview, and we can give this bluish color to the windows, which is the panel, and a black color to the frame. Okay, and here you can see it easily. You can have that preview for the windows. Okay, after producing the windows and the frames, I wanted to explain something here, and this is like deleting the first face, the first curve for the ground. As you can see here, this one doesn't have any extension here, and this is the most important part because we don't want to use this curve. And just to show you the output, let me turn it on. As you can see here, if we just get the curve we had this in the split tree, it's not going to sit down on this part. So what we have to do here is to go and play around. Let me explain this, and delete this part and go to here and pick up like the first curve again. So if you want to do that, what you can do here is to pick up the 1 because we deleted the 0. You can also use another technique, set tree, and use the tree branch. Remember, it has to be simplified, so it is 0 without zeros here. And what we want to do is to pick the 1 here. Just give it group 1. This one you don't need to add a data path. It's going to automatically convert that into that, and we get the data branch here. Okay, so now we have the last one here, and what we want to do here is to move it down in the -z direction. And it's going to be the facade, so it's going to be the subtraction. As you can see here, it's sitting down on the ground. And now we can offset that again. So again, we're going to use offset loose. Let's give this a number. For example, like this. If it has an intersection, even if we use this boundary surface, you can see that's going to fix it, right? So we don't get rid of that part. We just play around with it. Okay, and now we can extrude it back the same amount of the roof thickness. So again, let's use this freeform extrude in the Z direction, and the same as the roof thickness. Okay, I'm going to turn on here, and also let's give another color for the ground. Maybe yellowish color is going to be fine. So I'm going to give that to the ground, and here we go. We can again give this beer edge. I think that I turned off the beer edge here, so just give that beer edge to the panel frame is going to be, and also the roofs, just for visualization. I usually like to go here and select the document preview setting and put this to black. As you can see here, it's going to show you a black output, so it's good for visualization. Document preview, black, and if I hit OK, it's going to be really cool. But anyway, if you don't want to mess with the red one, let's go to the rendered mode. You can see that we have this as an output. Okay, at the end of this tutorial, I guess that we had to give this extrusion downwards, so I'm just going to give that -6. I forgot that it's going to go down anyway, and that's the last trick I wanted to explain. And if you get those points separate, remember that play around with the point of intersection. This is going to affect the final results. and you can get the outputs as this tutorial. Remember that you can download these example files all from our website, parametrichouse.com. And remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.